Hello everyone, I welcome you in this video, especially grade 9 learners that I'm working with. Nobuhle Karabo, Sbahle, Olwethu, Adorable, Sana, and Natasha. So, I welcome you in this video as I promised that I was gonna make a video for you. This is Mr. Thwala, so this is the video that we're gonna be talking about. So, we are still on the topic of straight line graphs, okay, or linear graphs, okay, and we have discussed two concepts: graph interpretation and understanding the features of linear graph. Okay, so this is what the video is gonna be about. So without wasting any time, we know what are linear graphs. They have to have this form of an equation, as you can see, where this is a gradient y-intercept. We're still gonna do more of this, okay, as time goes on, but the first part of the video is gonna be graph interpretation. It's gonna be graph interpretation, so please follow up. So with graph interpretation, I've explained with you, okay, these three basic things that you need to know about graph interpretation: what is meant by linear, what is meant by non-linear, what is meant by constant, increasing or decreasing, or discrete or continuous. Okay, so these are the things that we have discussed, okay, in class. However, I'm still gonna remind you once again, because of course I want you to always put this in your mind, right? Okay, now let's go. We said linear means straight. It means your graph is straight, okay, from the beginning or from the point you are looking at to the end point you are looking at. Okay, what does it mean? The first thing that you must know, whenever we read a graph, okay, whenever we read a graph, we read it from left to the right. From left to the right. We read the graph from left to the right. We read the graph from left to the right. Okay, that's how we read our graph. So when your graph is linear, okay, it means your graph is straight. Okay, straight in which sense? It means your graph goes in one direction, okay, from left to the right without changing direction. This is linear. This is a straight graph. Okay, why? Because it goes in one direction every time and from left to the right. Okay, a non-linear graph is a graph that is not straight. It means it changes direction. It might bend, it might turn a point, it might change direction. It's not straight. Okay, we discussed about those things. It's not straight. Then a constant graph is a graph, okay, for example, let me just put this here first. A linear graph, we said it should be straight, no change of direction. Okay, or should I just put it easy for you? Okay, easy to put in mind. It has, make it easy for you, it has one direction. It doesn't change direction. Then the non-linear, okay, non-linear changes direction. Okay, linear means straight, doesn't change, it has one direction. Okay, non-linear means it changes direction. Okay, changes direction. That is what you must keep in mind. Then we have, once again, this part, okay, of graph interpretation, which is called a trend. Okay, a trend is telling if our graph is constant, okay, or our graph is decreasing, or our graph is increasing. Okay, it's just telling us those things. Now, how do you know that? How do you know if your graph is increasing or decreasing or constant? Okay, I wanna make it to you as simple as I can. Okay, so a constant graph, okay, a constant graph it's a graph, okay, that is described or that has only one y value, okay, which is uh, which means that it only cuts the y-axis, okay, only cuts the y-axis and it goes constantly, okay. This is how you can have a constant graph. It means as you are moving from left to the right, okay, your graph is constant. It doesn't change its y value. If y value was 3 here, your graph from as you move from left to the right, it's always going to be 3 in y value. If you are looking to all the points in this graph, its y value will to all of those points in this graph will be y is equals to 3, okay. This graph is said to be constant. Someone can say it is a horizontal straight line graph, okay. It doesn't matter again also if it's cutting on the y-axis that is positive or on the y-axis that is negative. As long as it is a horizontal straight graph, it's fine, okay. Horizontal graph, it's fine, okay. So now, what is increasing? Increasing means that I'm not going to write about it, okay. Increasing means that as you are moving from left to right, it keeps on going up, okay. As you are moving from left to right, it keeps on going up. Decreasing means that as you are moving from left to right of your graph, it keeps on going down, okay. That's what it means. Clean. That's what it means, okay. Then discrete means your graph is in different points, okay. It's in different points, or your graph is in a point form, okay. If your graph is in different points, okay, or is described in different points, okay, it's called discrete, okay. If your graph is in a point form, it's called discrete. Then if your graph is a line, it's called continuous, okay. It's called continuous. If it's just, it is a line. If it's in point form, it's called discrete, okay. Discrete, okay. So now let us look to the questions quickly, okay. This is something that you have repeatedly done in class, so we should be able to easily grab it, okay. I was just reminding you, okay. Now let's look on these questions, okay. Let's look on these questions. Okay, we have number A, okay. Number A. For number A, is our graph linear or non-linear? Obviously it should be linear. Why? Because our graph is a straight graph, okay. It doesn't change direction, it goes in one direction. Is it constant, increasing or decreasing? This graph is increasing. Why? As you are moving from left to the right, it keeps on going high and high, okay, which means it's increasing, okay. Is our graph discrete or continuous? Of course, this graph is a line, it should be continuous, okay. Simple. That's how simple it is. Then let's get to number B. Is our graph linear or non-linear? If you look to number B, our graph goes from here, goes like this, goes like this. At this point, it was going down. Now it's starting to go up. Okay, so it has a U shape or a V shape. It has like this shape. Okay, this graph. It has a V shape or U shape. We can say V shape. Okay, now is this graph linear or non-linear? Of course, it cannot be linear. Why? It doesn't go in one direction. It goes down, then changes direction. Okay, then it's said to be non-linear. Okay, simple like that. Non-linear. Then, is our graph constant, increasing or decreasing? Wow. Okay, this is a a part that you need to put focus on. If we look to our graph, reading from left to right, we can't say it only have one behavior. Okay, it changes. It has two behaviors. Okay, or you can describe it, or it has two trends. Okay, this graph, as you move from left to right, it first goes down, then it starts to increase. Okay, so what you can say your graph decreases, okay, then increases. I'm sorry. Okay, so this is what you can say on your graph. Your graph increases, then decreases. Your graph decreases, okay, then increases. So that's how it is. Okay, it decreases, then it increases. Why do you say that? It's because you are reading your graph from left to right. It was gonna be wrong if you say it increases then it decreases. It was gonna be wrong, but it decreases first from left, then after it goes up. Okay, then if you are asked to explain an overall trend, okay, if you are asked to explain, or to provide an overall trend, okay, you don't have to say your graph decreases then what increases. You don't have to say all of that. Okay, if you ask about the overall trend. Okay, what were you supposed to say then if it was you were asked to explain or to describe an overall trend? You were supposed to say your graph is increasing. Okay, why? Because your graph it starts decreasing, but eventually, or at the end, it starts to increase. Okay, it starts to increase. So you can just say your graph is increasing if you say an overall trend. Overall trends means what is your graph doing, okay, as it moves from the right to the first, that's to the right. Okay, it's ended up increasing all the way. So this is the overall trend. But if you have to describe also in another way, you can say your graph decreases then increases. Okay, okay, so you can use an overall trend, or you can use this. Okay, but I prefer most of the time that you use this one: decreases then increases. Okay, then is this graph of ours a discrete or continuous? Obviously you have seen that our graph is in point form. It's not a line. Okay, our graph is not a line, so our graph is said to be a discrete. Okay, this is how our graph is said to be. So our graph is gonna be discrete. Okay, let's move to this one. Okay, okay, is our graph linear or non-linear? Obviously it's non-linear for C. Non-linear. Why? It's not straight, it bends, it changes direction, it's bended, it's not going straight. Okay, is it um increasing, decreasing, or constant? As you move from left to right, it keeps on going down, so it is decreasing. Okay, is our graph continuous or discrete? It is a line graph, so it should be continuous. Okay, for D, is our graph non-linear or linear? Look at the points. These points, they go like this. Oh, okay, seems straight, but all of a sudden it changes the direction. Now it's here, it's no longer straight. You see, it's no longer straight. This is not straight. Okay, so this graph is said to be non-linear. Why? Tell me why. It's not straight, it changes directions. We saw that with the points, they don't go straight. Okay, please be careful of such things. Linear means straight, doesn't change direction. Non-linear, it can change direction. Okay, now let's carry on. Is our graph decreasing or increasing? Okay, So our graph is decreasing. Why? Because as we move from left to the right, our points keep on going down. So it is decreasing. Okay? Is our graph continuous or discrete? Obviously, it's in points, so it should be discrete. It's simple. Okay? Let's look at this one. Is our graph linear or non-linear? Obviously, you can see it's bended. It's not straight. Okay, it goes like this and it curves. Oh, it's not straight, so it is non-linear. Okay, is our graph constant or increasing or decreasing? It should be increasing. Why? As we move from left to the right, this graph keeps on going high, up and up, so it's increasing. Okay, is our graph continuous or discrete? It should be continuous because it is a line. Okay, let's look on this last graph, f. Okay, so for f, is our graph linear or non-linear? It is linear. Why? Your graph is going straight down. It doesn't change directions along the way. It's linear. Is our graph increasing or decreasing or constant? It should be decreasing. Why? As we are moving from left to the right, it keeps on going down. So it is a decreasing. Okay. Is our graph continuous or discrete? It should be continuous. Why? Because it is a line. Simple. So that's how you simply interpret your graphs. Okay, please follow up to these things I've discussed with you. Make sure that you understand them. Okay, that's all. Now let's move on. Let's move on. Okay, so now we're gonna deal with graphs. Okay, we're dealing with graphs. We have mentioned that we are dealing with straight line graphs. Okay, and now we are going to a topic called interpretation of no, not interpretation, I mean understanding features of a linear graph. Okay, a linear graph is described by this equation: y is equal to mx plus c, where c is your y-intercept, where m is your gradient, where x and y represent any point that is on the graph. Any point on the graph. Okay, so this x and y can represent any point that is on the graph. You see, all of these points. Okay, you can put them there and there. Okay, it represents. Okay, it represents x and y represent any point x value and any point y value that is on the graph. And m is a gradient, and c is our y-intercept, which is this one, where your graph cuts the y-axis. Okay, where your graph cuts the y-axis. So if you can look carefully to this equation, okay, to this equation here, its gradient is 2 and the value of c is positive 1. Why? Because this graph was cutting at 1, okay, in the y-axis, and you can see its coordinates. It's 0 is to 1. It means this is our y-intercept. Okay, so this is what we're going to be talking about. So I'm going to give you different cases of problems or tricks that you must understand so that you can be able to calculate and get all every time all the features of your graph. Okay, so that's why we are in this point. For each of these graphs given below that we're going to be discussing, find the following: find the gradient, find the equation of a straight line. Okay, find the y-intercept, find the x-intercept. So that's all. Find the y-intercept and find the x-intercept. Y-intercept, we know x is 0. X-intercept, we know y is 0 in the point. Okay, so that is what you are looking for. Our gradient is given by the formula. Okay, some uses a and b, doesn't matter. Okay, the formula is just like this. Okay, it means that it's just a difference of y values over the difference of x values. Okay, but make sure that if it's y2 there, it should be y2 here. Okay, the x2 here below. If it's y1 there, it should be x1 below. Okay, that's what it means. So these are the features of the linear graph. If you fully understand how to calculate these things, you're not gonna have a challenge. Okay, most of the challenge in understanding linear graphs, because this is what the core, okay, or the basic information lies on. Okay, okay, now let's start working together. Okay, yesterday, oh, okay, yesterday, okay, or should I say from our last class, we discussed that every time when you have to deal with linear graphs, okay, let's say you are given a graph, then you have to find the equation of a straight line. Always know that you'll always be given at least 2 points, okay, or else you might be given a gradient or a point. Okay, so right now we're gonna explore all of those ideas together, okay, and see how can we solve. Okay, so remember, our first one is to calculate the gradient equation of a straight line, y-intercept, x-intercept. Okay, let's go. Let's not waste time. Now, very, very important. Okay, when you need to create a gradient, you need to have 2 points. Okay, you need to have 2 points every time. When you have 2 points, you can always calculate the gradient. Okay, the gradient. Now, how do you what do you do? The points that you must use to get a gradient must be the points lying on a graph. Okay, okay, not just any point that you can find. Okay, but only a point lying on a graph. Okay, like this one. So when you, the first thing you must do, label your points. Okay, so that you can easily substitute. So I'll call these ones x1, y1. Now call this one x2, y2. Okay, then I put them on the equation. Y2 is 2 minus y1, which is 5. Okay, x2 is 5 minus x1, which is 1. 2 minus 5 is negative 3 over 5 minus 1 is 4. That's all. Okay, this is our gradient. Simple. Okay, then here comes the important question. How can we get the equation? We found our gradient. Okay, we found our gradient. We found our gradient, son. No? So now, how can we find our equation? X plus c. In our equation, we need to have a gradient and we need to have a value of c. And a value of c is our y-intercept. We always know that. Okay, but now we don't have a y-intercept on the graph. I think we all agree on that point. Okay, our graph, it didn't give us a value of y-intercept. Okay, what do you mean, Mr. Thwala? What do you mean? It means this point we don't know what is it. Okay, this point we don't know what is it. Okay, so we can't just have a value of c. But so far our graph, our equation has negative 3 over 4 as our gradient, x plus c. Okay, then what's now you need to find? You need to find the value of c. Okay, now how can you find the value of c? Listen carefully. To find the value of c, you need to solve for c in this equation. And to solve for c in this equation, you must at least have the value of x and the value of y. How can you get the value of y? Use any point. Okay, any point on your graph. Use any point on your graph. Let's use 1 is to 5. How are we going to use it? You're going to substitute x as 1 and y as 5. Okay, remember what I said previously here. I said y and x, it means that it represent any point that is on the graph. Same thing here. Let's work it out. So for y, I'm going to put 5. You can even use this point. Try to use this point at home and see if you're going to get the correct answer. Okay, negative 3 over 4, and our x in brackets, right? I should put 1 plus c. Okay, then I can multiply here. Obviously, anything multiplied by 1 is going to be just negative 3 over 4 plus c. I transpose this to the other side. It's going to be 5 plus 3. Transpose means you're taking this to the other side. It's going to change the sign. Okay, and now let's work it out. 5 plus 3 over 4. That gives you 23 over 4 if you punch it on the calculator. So our C is 23 over 4. Okay, so that's what you need to do. So our value of an equation, okay, as we follow the steps, it was found to be 23 over 4. How simple is that? Okay, it's very simple. So our equation is y is equal to negative 3 over 4. Is it plus or negative? Since our c was positive, as we solved here, so you should put a plus over 23 over 4. And this value, if you punch it on your calculator, is like 5.75. Okay, so this is our equation. I hope you will understand each other. Okay, so can we move? Let me erase and get to the next question. Our next question was saying find the x-intercept. Our next question was saying find the x-intercept. So Garabo, we know that every time when you have to find an x-intercept, okay, we can either take it from the graph if it's given, or else we can calculate it. And we said, Garabo, when we calculate our x-intercept, we can use our equation. Okay, which one is that equation? The one that we just did. Okay, y is equal to negative 3 over 4 x plus 23 over 4. Okay, to get an x-intercept, okay, you let y equals to 0 every time. When you have to get an x-intercept, you let y equals to 0 where? In your equation. Okay, in your equation. So let's do that. Our y now is 0 in this equation, negative 3 over 4 x plus 23 over 4. Okay, then let's try to solve, okay, for x, so that we get x-intercept. We're going to take this one to the other side. It's going to be negative 23 over 4. Then we're going to have negative 3 over 4 x. We took this one to the other side. It changes sign. Then after, I know you like to do this, you divide by negative 3 over 4 on both sides. Okay, or you divide by the coefficient of x. Okay, this cancels this one, and x is going to be what you get here. So when you divide negative 23 over 4, okay, are we following? Negative 23 over 4 divided by the negative 3 over the 4. That gives us our x to be 23 over 3. Okay, which means our x-intercept, and it's positive by the way, our x-intercept is gonna be 23 over 3 is to 0. Okay, simple. Very, very simple. So, adorable, this is how we write our answer, right? This is how we write our answer. Okay, let's move. We need to also calculate our y-intercept. We need to calculate also our y-intercept. Y-intercept, y-intercept, y-intercept. So again, we mentioned previously that we can, our y-intercept is actually our value of c. Okay, it's actually our value of c. Okay, it's actually our value of c. Okay, so our value of c is this part. Okay, so our c in this equation is 23 over 4. Okay, so which means our y-intercept, okay, is 0 is to 23 over 4. That is positive. Okay, so this is our y-intercept. Simple. Okay, can we move? We're still on the same questions. Find the gradient equation and all of this. Okay, now this is the second case I want you to understand. Okay, you are given a graph, and in this graph they gave you 2 points, but there's something special about these points. This is an x-intercept. Why is it like this? Why is it like this always? Because this is where your graph cuts the x-axis. Okay, so this is our x-intercept. 5 is to 0. Okay, this is our y-intercept. Okay, why? Because it cuts on the y-axis. This is a point on the graph and also cutting the y-axis. 0 is to 5. Okay, simple. Okay, so we already have our y-intercept and x-intercept. We need to get a gradient, okay, and the equation of a straight line. So in this case, it's not like before. Before we were just given 2 points that are not necessarily the x and y-intercept. Okay, here we are given 2 points now that are just x and y-intercept. Okay, look at it. Now let's get the gradient. To get the gradient, we know our formula and we use our points. Label them. Let me just first label this one. Okay, x1, y1, x2, y2. So my y2 is 5, my y1 is 0, my x2 is 0, minus, put the minus sign, right? My x1 is 5. 5 minus 0 is 5. 0 minus 5 is negative 5, which gives you negative 1. Okay, that's our gradient. Okay, which means from our equation, okay, we're on number 2 now. Our equation is we want to find our equation of a straight line. Okay, gradient is already calculated negative. You can put 1 or you can just leave negative. We know that there's an invisible one. Negative x. What is our c? We know our c. You know how can you get it? We don't have to do the long way like how we did it before, where we use another point, you know, where we use another point, any point on the graph, okay, and substitute and get the velocity. You don't have to do that. Here we have our y-intercept already. Okay, so we can just find our value of c. And if anyone can tell me the value of c, we'll say it's 5. Why? Because that is where your graph cuts the y-axis. Okay, it's a y-intercept and it's 5. So the value of c is 5. So this is our equation of a straight line. So when you are already having a y-intercept, you don't have to calculate c, you already have it. So that's how this equation is correct. This is the second case. This is the first case, case 1. This is case 2. Okay, let's go to case 3. Okay, in case 3, Natasha, in case 3, this is what's happening. Okay, this is what's happening in case 3. You are given an x-intercept. These are x-axis, these are y-axis. and another point that is also lying on the graph. Okay, so adorable, the first question was saying to us, find the gradient, right? And the question is, can you find the gradient here? Yes, you can. You have 2 points. You have 2 points. You can find the gradient. Okay? You can find the gradient. You have 2 points. What can stop you? Nothing can stop you. Okay? So label a point x1, y1, x2, y2. Easy. y2 is 0, y1 is 2, x2 is 2, x1 is 3. And if you do this, negative 2, 2 minus 3 is negative 1, and that gives you a positive 2. Simple, right? Now, this is your gradient. And the next question is to say, find an equation of a straight line. Can we do that? Let's see. Our gradient is already, equation is y is equal to mx. Our m is already 2x plus c. And the question is, do we know what c is? No. We don't have a y-intercept. We can't see it. We can't see where it's going to cut. Okay? If I would continue this graph, maybe our y-intercept was going to be here below. If we continue this graph, it's just going to cut there. Okay? In the negative y-axis. Okay? But it's not there. And the question is, Nobuhle, how can we get it? I've told you, Nobuhle, how to get the y-intercept. I've told you. Definitely, I've done that before. Okay? And what did I say, Nobuhle? I said, if you want to find c here, use any point on the graph. Let's just use this one. Okay? Let's just use our x-intercept. In our x-intercept, this is our x value. This is our y value. So we just put a substitute there. Our y value is 0. Our x value is 2. We put 2 there. You see, now we're left with c. Let's solve for c. Okay? 2 times 2, remember bracket means multiply. 2 times 2 is 4. Take 4 to the other side, it's going to be negative 4. And you're going to left with c. So c is equal to negative 4. Therefore, our equation is going to be 2x minus 4. This is it. Okay? Nobuhle, this is our answer. Simple. Okay? And we're left with few questions. Nobuhle, we're left with few questions. What is your x-intercept and what is your y-intercept? What is your x-intercept and what is your y-intercept? Well, Nobuhle, we know that we have our x-intercept already. Our x-intercept is given to us where your graph cuts the y-axis. Is said to be 2 is to 0. Your y-intercept, well, Nobuhle, you don't have to struggle. Look to your equation. It's negative 4. Okay? Don't just say 4. Negative 4 goes with the sign. Okay? So your point is going to be 0 because in the point of y-intercept, x is 0. And your value of c is negative 4, so you're going to put negative 4 there. Okay? Cool. You got sorted. This is your y-intercept and x-intercept. Okay. Now let's move to case number 4, which is our last case. Okay. Now, our last case says that what if you are given a y-intercept? Okay. It says that what if you are given a y-intercept, okay, and another 1 point. Okay. I guess we know previously that whenever you have 2 points, we can always find our gradient or equation of a straight line. We know that. Okay, when you have 2 points. So let's do that. Let's find, Natasha, now our gradient. I think we are much familiar with this now. Gradient y2 minus y1, x2 minus x1. Okay? Label your points. We have 0 is to 1 here. Is our point. We have 4 is to 3, just in case you can't see it. Okay? Then what Mr. Thwala is going to do is just label them. I'll call this x1, y1, x2, y2. Then Mr. Thwala is just going to put the values substitute to the equation. y2 is 3 minus y1, which is 1. x2 is 4. Be careful when you do this. x1 is 0. Okay, is that making sense, right? Then 3 minus 1 is 2. 4 minus 0 is 4. And when you do this, it's going to simplify to 1 over 2, because you can divide by 2 on both sides here to simplify your fraction. 1 over 2. This is your gradient. And you are left with one question, okay? I mean, not with one question. We are left with a second question to answer. What is your equation of a straight line? Your equation of a straight line is mx plus c. Okay? We know our gradient already. 1 over 2. Our value of c, you don't have to go far and look for it. Please, you don't have to do that. We already have our y-intercept. Our value of c is a y-intercept. Our y-intercept is 0 is to 1. So this 1 here, our y value of our y-intercept, is going to tell us what is the value of c. This y value is positive 1. So we're going to put positive 1 as the value of c. You don't have to calculate it like how we did to the previous question. So our equation of a straight line is already given to us. It's already given to us. What is it? Y is equal to 1 over 2, which is the gradient, plus 1, which is the y-intercept. Easy. Okay? Now, I want you to pay attention, grade 9, now, to this last part. I want to calculate now the x-intercept. Pay attention. I want to calculate now the x-intercept, which is our third question, right? Let me erase everything. Okay. To get a x-intercept, I mentioned in class with you that you can get x-intercept by using an equation. And our equation is, we have already calculated it. Okay? It's y is equal to 1 over 2x plus what? It's plus 1, right? This is our equation for this graph, right? Now, how can you get an x-intercept? You have done this, right? You let your y equals to 0. Why are you calculating it here, Mr. Thwala? Why? Because we don't have it on the graph. Okay? We don't have it. If we continue this graph to this side, we see that it might cut there, but we don't have it. Okay? So what do? We are here. We use our equation of a straight line and say to get x-intercept, we let your y to be equal to 0. Then from our equation, we're going to let y equal to 0, 0. Then 1 over 2x plus 1. What do you do after this? You solve for x. Take 1 to the other side. It's going to be negative 1. Okay? I'm going to do the way that you usually like to do it. Okay? To solve for x, you like to divide by the coefficient, right? So I'm going to do that for you. Divide by the coefficient. 1 over 2 of x, right? 1 over 2. This cancels this. Then negative 1 divided by 1 over 2, it's negative 2. Okay? So when this cancels x, is going to be, when you divide this, it's going to be negative 2. Okay? So our x-intercept is negative 2 is to 0. Negative 2 is to 0. I hope that is much clear to you. Okay? Now, this is your x-intercept, noble. Okay? X-intercept. How did you solve it? You use the equation, let y equals to 0. Okay? Now, what is our y-intercept, which is our fourth question, if you still remember. Okay? Oh, I started with x-intercept. Okay? Let's get our y-intercept. Okay. Our y-intercept, okay, is already given to us. Okay, it's 0 is to 1. That's why our graph cuts. Sorry, I wanted to erase. So it's where our graph cuts, right? Our graph cuts. 0 is to 1. So this is our y-intercept. So we answered all questions. So please pause the video when you need to pause. Try to work it on yourself, okay, and try to use other ways. Like here, you can get a y-intercept also by letting x equals to 0 in the equation, okay. So try to be free and pause the video and try to make sure that you understand each and every step, okay. If I'm talking fast, okay, try to pause it and listen carefully. So we have discussed the first two checkpoint topics, okay, that we know in our graphs, okay, which is graph interpretation, okay, as well as understanding the features of graphs, okay. So please rewatch the video over and over. I want you to completely understand these things, okay. They're very, very important. So that's what we have for this session. Just have a nice time watching the video, okay. I'm sorry if there's some background issues, okay. um, please forgive me for that, but try to listen carefully to the video and follow it up. This is all what we had on this video. Cheers.